Alright, today we're going to talk about trapezoids and kites. A trapezoid is a quadrilateral, meaning it has four sides. Okay, but what makes a trapezoid a trapezoid is it has one pair of parallel sides. Which is different than a parallelogram, which in the parallelogram family you got a rectangle, a square, and a rhombus. All those types of parallelograms, they have all opposite sides are parallel. In other words, they have two different pairs of sides that are parallel, where a trapezoid only has one pair. And you can see over here at the diagram at the right, the quadrilateral A, B, C, D, that with these marked red arrows right here, they're showing you that only BC is parallel to AD, but they don't tell you that AB is parallel to CD. With that being the case of only having one pair of parallel sides, then this quadrilateral is a trapezoid. Now, there are some special parts of a trapezoid, and the first part is the bases. And there's actually two bases in a trapezoid, and it's the sides that are parallel. So we already talked about that BC and AD were parallel to each other. So they're the bases of this trapezoid. The parallel sides are the bases. So you could write that, or also you could, in parentheses, you could put the parallel sides, and we'll use the parallel symbol. Okay, and then the legs are your remaining parts. So you have AB over here, and I'll put a star over here by AB and a kind of a star over here by CD, but those two sides are the legs of the trapezoid. Those are the two sides that aren't parallel to each other. So we might put here in the blank that AB and CD are the legs, or the non-parallel parts, or not parallel, however you want to word that. Okay, and then you have your base angles, but we'll get more of that here in a little bit when we get to the next type of trapezoid, because there is another type of trapezoid, and it's called an isosceles trapezoid. Now, it's a trapezoid because it still falls under the same conditions as a trapezoid. It's a quadrilateral, meaning it has four sides. Okay, and then it still has one pair of parallel sides. But what makes it a isosceles trapezoid is that besides being a quadrilateral and having one pair of parallel sides, the other, or the legs, are congruent. In other words, when you look at the diagram above, this one right here, okay, you can see you have your, in red, you have your two sides here that are parallel to each other, so those would be the bases of the trapezoid. And then in black you can see you have this side over here on the left and this side over here on the right. Those are the legs, and they're congruent to each other. And so that would be an isosceles trapezoid. So we have a couple theorems we want to get to. I can go ahead and read them to you as you read them along with me. It's not showing up on my notes, I don't know why. But the first thing you see is theorem 7.14, and it's the isosceles trapezoid base angles theorem. Well, and you will have this on your printout, but also I'll go ahead and draw what you will have. You have this isosceles trapezoid, ABCD, okay, and you have this side here that is parallel to that side, and so since that's my parallel sides, then my remaining sides, they're in red, those are my congruent legs. Well, you have some base angles. Okay, for instance, you have angle A and angle D they're on that one base, and they're congruent to each other. So angle A would be congruent to angle D, and they would be a pair of base angles. They're one of your base angles that you have. Okay, and then you also have another pair of base angles, and we'll do those in red. You have angle B and you have angle C. They're another pair of base angles, because remember, you have two bases. So since you have two bases, you have four angles, so you have two different pairs of base angles. And so angle B and angle C are congruent to each other, and they're also base angles. And then you have another theorem, and I don't know again why it didn't print out on my iPad, but it will be on your printout. It is theorem 7.15. And what 7.15 says is that an isosceles trapezoid base angle is converse, and all it's saying is if a trapezoid has a pair of congruent base angles, then it's isosceles. In other words, for instance, let's go back up here real quick. In this example up here, you were told that you had an isosceles trapezoid because you had the two congruent sides. Well, that's why you knew the base angles were congruent. Well, in the converse, the opposite is being told first. The opposite is being said that in this trapezoid here that I'm drawing, we'll call this, just to give it a different game, we'll call it X, Y, Z, M. I'm just making up something. But in this trapezoid, it's a trapezoid. Okay, this X, Y, that's supposed to be an arrow. And MZ, that's supposed to be an arrow. Those are my parallel sides. But what I'm going to tell you here in this one is that you have one pair of base angles congruent. Well, that's all you need. That's enough right there. I don't need to tell you that the base angles X, Y are congruent. Just by me saying that M and Z, they're on the base, because that's one of the parallel sides. So I have a pair of base angles that are congruent, and since I know that, then I know that this is isosceles. So let's think about this. If this is an isosceles trapezoid, okay, then what sides would be congruent? Think about it for a minute. That's right. MX and YZ, those would be my legs, so they would be congruent. Again, remember, your bases, your two parallel sides will never be congruent to each other in a trapezoid. They're only going to be parallel, and your legs, your other pair, would be the ones that are congruent. And then you have another theorem on your on the bottom of your page, and it talks about the isosceles trapezoid diagonals theorem. And all that's saying is if your object is isosceles, if it's an isosceles trapezoid, that the diagonals are congruent. And I'm going to go ahead and use the converse diagram because I'm running out of room. But what they're telling you is if I go diagonally from one of the base angles to the other base angle, here I went from XZ, and then I go catty corner or diagonal in the other, M to Y, those two diagonals right there, and I'm going to write this in red, that MY, that diagonal, is congruent to XZ, but only if it's isosceles. Oh, for whatever reason, here's these theorems I was talking about. Let's go ahead and review those three theorems that we just talked about. This first one here, this is talking about if I have an isosceles trapezoid, knowing that I have one pair of sides that are parallel, these two sides here, and you're told that I have a pair of congruent sides, my legs, excuse me, then my base angles, angle B is congruent to angle C, and angle A is congruent to angle D. The second theorem here, that was the second one that I covered, was the isosceles trapezoid base angles converse, which says if I have a trapezoid and I have one pair of congruent base angles, for instance, angle A is congruent to angle D, then that's enough for me to say that this trapezoid is isosceles. In other words, you would know that AB is congruent to CD. And then the last thing was that if I have an isosceles trapezoid, not every trapezoid, but if it's isosceles, then my diagonals are congruent. And you can see in this diagram, right, just a quick review, that AC, that diagonal, is congruent to BD because this is isosceles. Okay, it has to be an isosceles trapezoid for the diagonals to be congruent. If it's any other trapezoid, then that wouldn't hold true. Alright, so let's try to apply some of our theorems. I'm going to do a few with you, and then I'm going to let you guys try them. And in this one right here, we can see we have this trapezoid right here, and this, it looks like some stonework or something in this. It's a real life object. But the stone above the arch in the diagram is an isosceles trapezoid. So isosceles means we have two congruent sides, and you can kind of see right here that KJ, this side here, is congruent and equal to LM. Okay, since that's the case, then your base angles are congruent. So remember, our bases, okay, our bases are the two sides that are parallel. Well, you can see the arrow right here showing that it's parallel to this side over here. So KL is parallel to JM, so those two sides are the bases, and so those angles that are attached or part of that base are congruent. So angle K is a base angle and congruent to angle L, and angle J is congruent and a base angle with angle M. Okay, not a very good M. Okay, and they give you one angle measure, and they want you to find the rest of them. Okay, well, you can find one angle pretty easy. I mean, right here they tell you that angle L is 85 degrees. Well, K is angle L's base angle partner, so that means angle K also equals 85 degrees. Well, so kind of got to go back a couple lessons. Don't we know we have a quadrilateral, so we have four angles. So isn't there a way that we can find out what the total angle measure is of a quadrilateral? And if you don't remember, you would remember the formula. The number of sides minus 2 times 180 would tell you the degree measure of any object. If you know the side, number of sides, subtracting by 2, multiplying 180. Well, there's 4 sides minus 2. 2 times 180, that would be 360. So I know that I have a total of 360 degrees. Okay? Well, I have two angles. Angle L and angle K are both 85 apiece. Well, let's go ahead and add those two together. So 85 plus 85 is 170. So I can account for 170 degrees of the 360. So let's go ahead and take the 360, the total of all the angles, and subtract 170. And what you're left with is 190 degrees. Well, let's talk about this for a little bit. I have 85 degrees, or I have 170 degrees in these two angles. I have 190 degrees, I'm circling in black right here, I have 190 degrees that has to go into those two angles. And aren't those two angles, angle J and angle M, congruent? So doesn't that 190 degrees doesn't have to divide up equally into those two angles? And that's right. So I just need to take 190 divided by 2. Not minus 2. I don't know what I'm doing here. I needed to divide by 2, excuse me. Okay, and so that would give me 95. So angle J and angle M both equal 95 degrees. And so if you added 95 plus 95 plus 85 plus 85, you would get 360 for your total. And if you add stuff up and it doesn't equal 360, then you know you have something wrong because it's a quadrilateral and it has to meet those conditions with the angles. Alright, so what I'd like for you to do is I would like for you to do example 2 and example 3. I won't be there when you do these lessons, but I have given the sub the notes and the answer key. And so when you come up with the answer on your own, or if you're stuck, just raise your hand and the sub can either A, tell you you've done it correctly, or B, to get you going back in the right direction. Alright, now we have to talk about a midsegment. Now, we already done a midsegment earlier in the year. We did the midsegment of a triangle. The midsegment of a trapezoid is somewhat similar, but not completely. Okay, but if I have a trapezoid and I have a midsegment, then my midsegment is parallel to both bases. Remember, there's two bases in a trapezoid, so it's parallel to both bases. Oops. Parallel to both bases, and it equals half the sum of the bases. Now, what does it mean when we say the sum of something? That's right, that means we've added stuff together. So if I have two bases, and whatever they add up to, well, if I have a midsegment, I just divide it by 2, and it gives me the midsegment. For instance, I'm going to use this diagram that goes with theorem 7.17. And I'm going to go ahead and just give some random measures. Let's say I told you that AB equaled 10 and DC equaled 20. Well, those are the two bases of the trapezoid. And then I'm going to tell you that MN here, this segment right here in the middle, is a midsegment. Notice that it is parallel to both the bases, the base AB, that is 10, the base DC, that is 20. Well, if I want to know how long MN is, all I have to do is take the sum of the two bases. Well, 10 plus 20, that's the sum of my two bases, which gives me 30. I would divide it by 2, and I would get 15. And so that is what MN would equal. And that's what this theorem is talking about. The midsegment of a trapezoid is parallel to each base, and the length is 1/2 the sum of the lengths of the bases. All right. Okay. I don't want to work all of example 4, proving that this object is a midsegment. In other words, they want to know, is this segment here, YZ, a midsegment? Well, for it to be a midsegment, doesn't its measure have to be half the length of what the two bases would be? In other words, you would take SV, whatever it equals, plus UT, and you would take that total right there and you would divide it by 2. Okay, and as long as that, if that, whatever that equals, if that's what YZ equals, then it's a midsegment. Well, all they give you is the coordinates of this, of the trapezoid. Well, you would have to do the distance formula. You would have to do the distance and find out what SV equals, which SV, I don't have a calculator on me, but SV ends up equaling, it's about roughly, SV is about 4.6, I think. I could be off just a little bit. And then UT is about 8.9. Okay. And when you put those in the calculator, well, if I add those two together, I could go ahead and let's see, that's going to be 5. Here's the 1. It's going to be 13.5. Well, that's the total of those two. That's the sum. Okay. Well, if I divide that by 2, I would get 6.75. Okay, and so that's what the midsegment, that's what YZ would have to equal. Well, okay, you know where the points are of this of YZ is. Just do the distance formula with the points that YZ is, and if it equals 6.75, then you know it's a midsegment because it's half the measure of the sum of the bases. Okay. All right, and then here's your other and last and final quadrilateral, and it's a kite. Okay. In a kite, again, it's a quadrilateral, so it does have 4 sides. Okay. But what makes it be a kite and be more than a quadrilateral is the adjacent sides are congruent. The adjacent sides are congruent. Okay, and I would rather draw this than give you a big wordy definition. But a kite is a quadrilateral, so it has 4 sides. Okay, and we'll go ahead and call this the kite, I don't know, it doesn't matter. We'll call it the kite A, B, C, D. And what they mean by adjacent, we've dealt with the word adjacent. But remember what adjacent means. Adjacent means next to, or you share something. For instance, this side right here, AB, and this side here, AD. Don't both of those sides share that point right there? So they're adjacent to each other. So AB would be congruent to CD. Okay? And then not only that, but then you have this side over here, BC and DC. Well, they're adjacent, and they share this point here, C. So BC would be congruent to DC, and that's a kite. There are no parallel sides in a kite. Okay? There's no sides parallel in a kite. You only have congruent sides. Now, there's one more thing about a kite. Okay? And I'm going to draw a smaller kite here in black at the bottom. Okay? So I'm going to go ahead and give the tack marks, showing that the adjacent sides are congruent. And one more thing about a kite. I'm going to go ahead and connect and draw diagonals. So I'm going to draw this long diagonal right here. and I'm going to draw this other diagonal right there. In a kite, you always have the opposite angles that are opposite. I don't know how to explain it, but this side right here, this side to this side, these two angles are always going to be congruent. It's the shorter, it would be the shorter distance, I guess, would be the best way to know it. Or going from one tack mark to two tack marks on the congruent sides. You know, this angle right here is the angle that is in between the side over here that has one tack mark and the side over to the right that has the two tack marks. And so that angle is going to be congruent to its opposite side. So and the diagonal right here is bisecting. And one other thing, when the diagonals of a kite intersect, they are perpendicular. In other words, notice, don't I have 4 right triangles being made right there? So a couple things as we move forward. And here we just what we just talked about, so it's kind of like we're reviewing. But as you can see, if a quadrilateral is a kite, then its diagonals are perpendicular. So as you can see, they have my diagonal BD that goes this long distance of that kite, and then you have the other diagonal CA, and when they intersect, it's perpendicular, which means you have 4 right angles. Then in the second theorem, 7.19, it's the opposite angles theorem. And maybe this drawing is a little bit better, but in a quadrilateral, the kite has exactly 1 pair of opposite angles congruent. Only 1 pair. Only 1 pair. And again, remember, look, you have CB right here has the 1 tack mark, and you have CD has the 2 tack marks, and that angle in between, angle C, is going to be congruent to the opposite side that the angle that's in the same position. Notice, look at angle A, how angle A is in between the 1 tack mark of AB and the 2 tack marks of AD. So those 2 angles are congruent. Angle C is congruent to angle A. So what I'd like for you to do is I would like for you to do example 5 and example 6. I will give you a little hint on number 6. You need to do guess, check, and revise. Okay, that would be the best way to do that, so that you can figure out. And I will give you a little hint that this. Remember, you always have 1 pair of angles that are congruent. This 3x right here is equal to one of those other 3 angle measures. You just got to figure out which one. All right, now you're on the last page, and this just kind of diagram. I don't want to get too heavy into that. It's just showing all the different types of quadrilaterals. I can see rectangles, rhombuses, trapezoids, parallelograms, isosceles trapezoids, and kites all in this, because all of those are in the quadrilateral family. Okay, or you can just have a quadrilateral where nothing's congruent, nothing's parallel. For instance, this object right here looks like a perfect candidate for it, because you can see nothing is parallel, nothing is congruent. It's just an object that has 4 sides. Okay, but I don't want to spend a lot of time on that. So let's go ahead and go down here. So here we're going to tie everything together. In example 6, they want you to name the specific name, or they want you to classify this quadrilateral A, B, C, D. Well, let's look at the markings. Well, the only thing that they tell you with the markings is that you have some congruent pieces on the diagonals. Well, I know what the object looks like. When I first glance at this object right here, myself, I'm thinking square. But I can't go by what I see. I have to go by what I can prove. And the only thing that I can prove is that with this part being congruent to that part right there that I've circled in red, and this portion being congruent to this portion that I've circled in blue, isn't that showing that E is bisecting the diagonals, or it's a midpoint? Sure is. And so all this object is, it's just a parallelogram. And if I wanted to give my reasoning, and we'll write that in black, is that the diagonals bisect each other. So I want you to do 8, 9, and 10. Give the most specific name for the quadrilateral. Explain your reasoning. When you're finished, raise your hand. Have the sub look and see how your answers are, because again, they have the key and know what the answer should be. When you're finished with your notes, then go ahead and begin the assignment that is attached on the back of the notes. And see you soon.